a lighthouse L is located offshore. So it's basically here, and it's given that it's 500 meters from the nearest point P. So this lighthouse is 500 meters from the nearest point P from the shoreline. So this one here is the shoreline. Um, so the narrow beam of light from the lighthouse, this is the narrow beam, yeah. Um, and the beam, of course, this is the lighthouse. So the beam is right here. So the narrow beam of light from the lighthouse rotates at um, a constant rate of 8 pi. So this rotates at a constant rate of 8 pi. Yeah, going like that. Okay, so basically, and that's 8 pi radians per minute. So that's the rate of change of this angle. So suppose we have an angle here, let's say theta, this rotation going like that. So the rate of change of this angle here, which is theta, yeah, is 8 pi radians per minute. So let's just come over here and say what is given in this question. So the given information. So the first thing that's given here, like I've just said, is the rate of change of this angle here, and that is d theta over dt, which is 8 pi radians per minute. And also, um, moving on, we have, of course, this distance is 500, and I'll discuss about that in a minute. Um, so moving on, we have so you may assume that the height of the lighthouse can be ignored and that the beam of light lies on the horizontal plane. So that's just a condition to allow this to work, to have a right angle triangle basically. And this is, by the way, right angle triangle. Yeah. So we can just add to that that LP is fixed um, at 500 meters. So this distance here is fixed as 500 meters. So what is the required information? So what is required in this question? Yeah. Um, is we are required to show that the speed of S correct to three significant figures, it is 214,000. Yeah. So basically, let's interpret it in a different way, that what's required is basically the speed of S, which is the rate of change of X with respect to T. So dx over dt, and this is the speed of S. And we want to find the speed at a specific moment. So when S is 2000 meters, as it's given in the question. So this is the given information, and that's the required information. Okay, so how do we start? From the diagram, of course, this is X, because this distance is changing. Yeah, so X, but we know that we want to find the rate of change of X uh, when uh, S is 200 meters from P. Okay, so from here, we have theta here. Yeah, so we have angle theta here. And then we have a right angle triangle. So from the diagram, we can come up with a relationship, because this is a right angle triangle. Um, trig ratios will be more suitable. So from the diagram, from the diagram, we know that this trig relationship is true. Tan theta will be equal to x over 500 because 500 is fixed. So that implies that x is equal to 500 tan theta. And because you want to find the rate of change of x, we can differentiate this implicitly. So d over dt of x should be equal to d over dt of 500 tan theta. Which implies that dx over dt will be equal to secant. So that the derivative of tan is secant of theta squared. So this will be equal to 500 secant of theta squared d theta over dt. Just similar to what we did in the previous question. And we can write this as dx over dt will be equal to 500 over cosine of theta squared d theta over dt. Now, at this moment, I just want to go back to this triangle here. And let's say when x is equal to 2000. So when x is equal to 2000, again from the diagram, so from the diagram, when x is equal to 2000, we have this relationship, yeah, tan theta. Actually, let me write it here. So, okay, tan theta will be equal to 2000. This is 2000. That will be 2000 over 500, which will be equal to 4. So let's consider a smaller triangle that's similar to this triangle, because for similar triangles the trig ratio will still be true even if it's a smaller triangle, on condition that it's similar to that one. So let's consider a smaller triangle, yeah, because we don't plan to use a calculator. Well, at the end we'll use a calculator anyway. So anyway, you have here right angle triangle and then theta. So tan theta will be, here we have tan theta is 4 by taking those ratios, so that will be 4. And 4 is same as 4 over 1. So that's just less 4 over 1. So we can come over here and say tan theta is 4 over 1. And by Pythagoras theorem, this length here will be square root of 17, which is 16 squared plus 1 square root of that, we have square root of 17. So that implies that cosine of theta will be equal to 1 over square root of 17. So how does this help us? It helps us here. From this relationship here, yeah, we can be able to plug in that in place of cos. So that implies that, therefore, dx over dt will be equal to 500 over square root uh, 1 over square root of 17 squared d theta over dt. And at this moment, we can notice that this is the same as 500 over 1 over 17, because square root of the square of a square root, those two cancel, so you just end up with that d theta over dt. Okay, so dx over dt is equals to that. Yeah. Okay, so let me just write this here so that you don't get confused on what's going on. So dx over dt will be equal to that. And this is the same as 500 multiplied by 17 d theta over dt. And by the way, dx over dt is given in the question. Actually, the theta over dt is given in the question because you're trying to find dx over dt. So the theta over dt is 8 pi. So we'll plug 8 pi here. So that will be equal to 500 multiplied by 17 multiplied by 8 pi. And if you plug this in the calculator, because you want to show that your answer to 3 significant is equals to that. Anyway, if you plug that in your calculator, you'll end up with 213,628. And to 3 significant figures, that is equal to that.